We're going to start this question now. The question is the dependent system. I want you to read it first. It's question 7. And this is usually what they do. In the final exam, they give you a question that's independent, similar to the one we did. And then they give you the same question dependent. Here it's the same concept pretty much, but now they wanna, instead of 10 people trying the medicine, 10 trying the standard and 10 trying the trial like the first question or the previous question. Here you have the same group, so one sample doing 2 tests. So they took the recording before and after, so the start and the end, and they recorded all of them. So one sample doing 2 tests, that would be a dependent system, also called paired sampling, when it's one group doing 2 things. They also give you all kinds of information. It's a sample of 10. The x of d, meaning the x of the difference, is 0.16, and the standard deviation for the difference also given, and that's 906. The question test at alpha 5%, so again alpha here is 5%. Whether or not the trial drug is effective, show your work and whatever. So they're going again. You have the start and the end. This is 1, this is 2. Now, in order for this to be defective, end must be less than the start. For this trial to be actually your opening, and they tell you in the question, it's effective when it's lowering the AIC. So we want the end, we want it to lower the reading, so we want the end to be less than the start. But if we do it in terms of the start, we want the start to be more than the end. So we're gonna do it with respect to the start because that's group 1, H0, HA. Since this is a dependent system, so we say mu d. For a dependent system, we say mu d. We want it to be better, so we say mu d. We want it to be, because we're going to do it to start more than the end, mu d greater than 0 versus equals 0. Then you say, okay, we need to know what the test being used here. The test statistics for a dependent system is you take the average d minus mu d over sd over square root of n. And you pretty much have everything. This number is given, and they give it to you. Mu d, according to this, it's 0. SD is the 906, and it's the square root of the sample 10. So you put everything in the calculator. The answer would be 0.56. So after doing this, we found the 56. We need to know what the p-value is. So I'm going to erase some of this. Sorry. P-value t we need to do the DTT, degrees of freedom, test, tail. For a dependent system, degrees of freedom is simply n minus 1. So it's 10 minus 1, it's 9. The value of the test we found to be 0.56, and since this is more, 1 tail. So you go to your t-table, you go down to the degree freedom 9, you look for this number. Again, you don't see the number because at degree freedom 9, the first number you see is 1383. That's the first number you see, 1383. And then numbers go up after this. And the one-tail percentage go down. So anytime you go this way, numbers go up and percentage go down. But your number is here. Your number 56 is actually more than this, so you gotta be more than whatever the one-tail percentage is. Now remember, if your number is here, more than the table, your percentage would be less than whatever the last percentage is. If your number is here, less than the table, or left of the table, your percentage would be more than whatever this is. And for one tail, you know it's more than 0, 10, or 10%. So your p-value is more than 0, 10, or 10%. Now, going back to the problem, your alpha given, if you remember, is 5%. So you ask yourself, is this more than alpha or less than alpha? Well, if you're more than 10%, your p-value is more than alpha. And remember what we said? P-value less than or equal alpha, reject H0, conclude HA, significant result. P-value more than alpha, you're not rejecting H0, you're not concluding HA, results are insignificant. You're not concluding HA, meaning we do not have evidence of this, don't have evidence that this drug actually works. No evidence of this. Okay, I'm gonna go back to the question now. Now the second part of the question, we did the first part. Now for the second part of the question is to do a confidence interval. But I can't, I'm just looking for here. Yeah, 99 confidence interval for the difference between them. So we're still in a dependent system, but we want confidence interval. So we need to do the same problem as confidence interval. So if we do the same problem as confidence interval, what's the confidence interval for a dependent system? So a hypothesis dependent system, this is the test. Confidence interval for dependent or paired sample, you take the x bar d plus or minus t star sd square root of n. To get the t star, you need to know your degrees of freedom, and the degrees of freedom is always n minus 1, and that would be 10 minus 1, 9, and whatever the level of confidence they're asking you to do. It's not so clear. Yeah, it's 95. Yeah, I saw it. It's 95 confidence interval, so we need the number from the t-table that corresponds to degree freedom 9 and 95 confidence interval. So I go to the t-table. The number that goes with the degree freedom 9 and 95% is 2.262. So your t star, 2.262. You put everything together. The average in the question was given 0.16. T star is 2.262. SD is 906 and a square root of 10. So you bring this number down, you do the calculation of 2.262 times 906 over square root of 10. This number is 6481, and then you know, you open brackets, you minus them, and you add them. Good. One thing that I want to talk about is when you do confidence interval, independent or dependent. So you do confidence interval, whether it's an independent system or a dependent system. You will end up with three cases. It could be that the first number is negative and the second number is negative. It could be that the first is positive and the second is positive, or negative positive. It's never anything else. It's one of those three. Only for confidence interval, independent or dependent. And then they ask you, based on this, are they different? Are the groups different? Or is one more than the other? Now, if they're both negative, you say they must be different. Reason is 0 is not within confidence interval. So if you get two negative numbers for confidence interval independent or dependent, then they must be different since 0 is not within confidence interval. And the fact that it's negative means second group is higher. Positive, positive also means they're different for the same reason. 0 is not within confidence interval, but now first group is higher. Negative, positive, that's the only time that is not different, since 0 is within confidence interval. Again, this is for confidence interval independent and dependent. So going back to the practice, we did the dependent question. We did the confidence interval, and then they tell you, after doing this confidence, let me see which question we were stopped at. We did the dependent question. Yeah, now the question we need to do is question here. Yeah, let Y represent the annual transportation cost of a randomly selected Canadian household, and they give you normal distribution. So let me just clean this. They tell you it's normal distribution, and they give you mu. They tell you mu is 6,800. They also tell you that the variance is 160, making sigma, which is always square root, sigma would be the square root of this, and that's 400. Write down the sampling distribution of the mean. So, okay, when they say sampling distribution, so it's the mean of a sample. Sampling distribution at n equals, they say 16. Sampling distribution, like we did with the proportion question. Remember, with the proportion question, there was mu proportion, sigma proportion. Here, there is mu and sigma as well, but this is the mu of the sample and sigma of the sample. Mu would be whatever the actual mu is. But the sigma, you take the sigma that you have and you divide it by the square root of n. So you take the 400 over the square root of 16, and that will give you 100. Then your distribution is now normal with mu 6800 and sigma of 100. Now, what's the probability? The question is a probability question. That's a single randomly selected household more than 700. The question is a single household. And since they call the household Y, I'm going to stick to the Y. It's usually X, but doesn't matter. A single household, then a single Y, more than 700. Or 7,000, is it? 7,000. In order to do any probability question, you need to take everything and represent it in terms of Z. And that would be Y mu sigma. So it would be 7,000, mu would be the 6,800, and the actual sigma. So I'm gonna, since it's a single, I'm gonna use the actual sigma for the single. So that would be 200, that would be 0.5. So in terms of Z more than 50, you're 1 minus table. So you go to your table, you see what's the percentage for a 0.5, you see it's 6915, so the answer would be about 30%. The C question. Now look at the language, because you'll see a question like this where you see the language, and you need to be careful. Now, we found the sigma for the sample to be 100 from the beginning of the question. Now in C, it's not the probability of a single, it's a probability that the sample mean is more. So now you have probability that the sample mean, meaning Y bar, is the one more than 7,000. Again, in order to do any question in statistics, we need to represent everything in Z. Now the formula is minus mu over sigma Y bar. So not the, if it's a single, you divide it by just sigma. If it's a sample mean that you're finding the probability for, you divide it by the sigma of the sample mean. So that would be 7,000 minus 6,800 over 100, that's 2. Probability Z more than 200, you're 1 minus table. If you go to the table to find what the 2 is, you'll see that's 9772. Answer would be about 2%. I'm gonna stop the video now, and I'll see you for the next part.